Hi guys, welcome back to the series SQL Query Optimization. So today we will be discussing tip number 3, which is indexing. So the first question that comes to our mind is, what is indexing? In simple words, indexing can be thought of as something like a phone book directory. Okay, so in phone book directory, all the names are sorted in an alphabetical order. So when we want to find a particular name, let's say like maybe my name Pritha. So if we want to find the name Pritha, we will first go to P, which will always come after M and O P. So it will always come after O. So we will first go to O, skipping everything before that. After O ends, only then will P come. So only after P comes, then we will search for R, right? So Pritha. So we will now search for R. So after P, we will again skip anything that starts with PA or PB, PE, everything. We will skip that and then go to R, right? So now we will skip until it's PQ, and then only then it will come PR, right? So like that, we will keep skipping it until we get the full name, which is Pritha, right? So indexing is kind of the same way. SQL does this whole sorting thing. It sorts all the names, or numbers or whatever it is in this column on which we have applied the index into an ordered thing. Like if it is numbers, it will sort in like in ascending order. Okay, or if it is in if it is alphabets, again it will be sorted alphabetically in again the ascending order, right? So it becomes much easier for SQL to find something. So when we give something a condition like the ones we give in where statement, like where name equals to, let's say again Pritha, so it will again do that type of sorting. It will skip everything until O, and then come to P, right? So only after it skips everything until O, it will come to P. It will not see anything which starts with anything before that, because everything will be sorted in here. So the execution becomes much faster, right? So uh, now we can let's learn how this indexing works. Okay, so here we can see something like a chart. Okay, now what does this chart tells us? This chart mainly explains how indexing works. Now let's say the indexing is something that is created by a create statement, right? So the statement there becomes create index. We give an index name, like let's say index name. Okay, so create index name on the table name, and within bracket comes the column name. Yeah, the column name on which we want to find, apply that index, right? So in here, let's say there is a table of people. Okay, so in that people name, there is a name column, and then there is some other columns. Okay, so on that name column, we had applied the index, right? I want to find the name Tyler, right? So now, how does this work? First of all, SQL will find a middle portion, middle name, right? So in here, it has chosen Simon as the middle name. So that is my root. Okay. From there, all the branching is starting. So Simon is my root. So I want to find Tyler. Now, this is sorted into another branches. One is Jennifer, one is Tyler. Now we have to remember that even if we see the name Tyler in here, this is not the correct address for it right now. It is just a pointer over here. This Simon is again a pointer. It is not the actual value over here. Okay, the values, all the values are present in the last row. Okay, so in the last row where it is Aaron, Amelia, Jennifer, all these here, these are this everything here. This is what the actual values are over here. This all everything here or here, anything that is not the last row, everything here, they are all just pointers. Okay, now here it is Simon, right? So I want to find Tyler. So we can see it has been branched into one is Jennifer, which comes before Simon because it starts with J and this is S. And one is Tyler, which comes after Simon because it starts with T. So alphabetically, J comes before S and T comes after S. So that is the branching here, right? So I want to find Tyler. So Tyler is after Simon, right? Now, again, Tyler has been branched into two parts. One is Suzanne, which comes before Tyler, and one is Zoe, which comes after Tyler. So SQL will also be working in the same way how I am explaining. It will first find the root and then see if the name which I want to find comes before that root or after that root. Like I want to find Tyler, so it comes after here. So SQL will not try to find anything which comes before Jennifer. It will always go after. Okay. Now it found Tyler. Now Tyler is again divided, right? So one is Suzanne, one is Zoe, right? Now I want to find Tyler. So where does Tyler comes here? Okay. So Tyler will not come after here, after Zoe, right? And but Tyler will again come after Suzanne, right? So what SQL will do is it will go here, Zoe, because Tyler will come after, right? So it will come here and then it will go down to Tyler, which is here, right? So this is how indexing works. It makes SQL work much less than it would have to work if it was doing a full table scan, right? Full table scan means there is no indexes mentioned. So what will SQL do in that case? It will try to find everything, search every single row for the name Tyler from the first to last. So let's take an example. Okay. Now let's see. I am here. So in MySQL, there is a default database called Sakila, under which we have all these tables called actor, address, category. I will work with this table. Okay. Now this table has these columns: first name, last update. Okay. So first I will create an index on here, right? So first I will use the database Sakila. Now let's first see what are the names here, right? So there are 200 rows in here, right? So you can see all these names. Now I am selecting a random name here, Penelope, which I want to find. I will just find here by the normal way. Select let's do a star here first. From actor where name, first name, it will be first name equals to Penelope. Okay, I'm finding this. Now there are multiple Penelopes as we can see, right? So now we will create an indexing over here, right? Now before that, let me tell you something. There is a technique called explain statement, right? So this, what does this statement do? It explains the execution plan of SQL, right? So I will be explaining the same thing. Select star right? So we will use this explain statement over here, right? Now what will this explain statement do? Let's see. Now see, here the query cost is 20.25, right? And rows examined per scan. Let's focus on this one. Rows examined per scan, right? So this one says it has examined 200 rows, which we already know that is the total number of rows that we have here. And rows produced per join is 20, right? Now let's create that index here, okay? So create index. I'm giving the index name. On the table name is actor, and I will be the column names are first name, last name, right? So this is the index that I am creating here, right? And now I will do the same statement once again, and I will explain it. Okay, sorry, I did a mistake here. Let's do it, try it again. Explain format equals to JSON. Select star from actor where first name equals to Penelope, right? So here we are again doing the same thing, and now I will explain it after I have created the index. Okay, now let's see. So first time my query cost was what? 20.25. And now what is my query cost? It is 1.15, right? Now see this. Rows examined per scan 4. Previously it was rows examined per scan 200. It examined all the rows that was there. But now it is only examining this 4 rows, which we got here. These are the 4 rows that they are examining, right? This Penelope, these 4 rows. And rows produced per join 4. So previously it was examining all the 200 rows, and now it is examining just 4 rows, right? So as you can understand from this query cost, which is much lesser than previously, which is 20.25, right? So you can see how indexing helps in optimizing the SQL query. And you can also use this explain statement to just understand what is the execution plan of SQL, by which you can understand how optimized your query is. Okay, the format is just writing the explain statement before. So explain format equals to JSON, select, and then you write your query. This is the only thing that you have to write before. Okay, so this part. So this is the only part that you have to write. Explain format equals to JSON to get this whole thing. Okay, this whole thing. Okay, 1 minute. To get this whole thing. So now you understand why indexing is so important for us. So there is now only one information that I want to give, that is SQL uses this B plus tree indexes, right? This is the type of indexing that MySQL uses, B plus tree indexing, right? Now, B plus tree indexing has a lot of benefits and disadvantages, okay? So the benefits are what? Match full value. A match on a full key value specifies values for all the columns in the indexes. So like we mentioned, we created a index on the first name and the last name. So we can mention both the things, like I want first name Penelope and the last name may be Garrett. Okay, so it will search for those two. Match on the leftmost prefix, like we did. We just did a where statement where the first name is Penelope, right? So that is what it is saying, match on the leftmost prefix. Again, it can also do a match and range of values, right? So we can give whose first name is Penelope or something else like Alice. Okay, it would have worked on that as well. Match a column prefix. So we can also do like pattern matching here, like with name who starts with just A or P or anything like that. So that is pattern matching here. B-tree indexing also works on that. And the last one is match one part exactly and then match a range on the other part. So we can say like whose name is equals to Penelope and the last name starts with G. So we can also do that. So B plus tree indexing works on that as well. Now on what does B plus tree not work? So B plus tree not works when lookup does not start from the left side, leftmost side. So what I'm saying is if I had written where last name equals to maybe Garrett, here the B plus tree indexing would not have worked because I haven't provided anything for the first name. B plus 3 does not work for that. And now any of the column defined in the index is skipped. So now I have only made indexes for 2 of them, but let's say I have made it for 3. So maybe in that table, date of birth was also mentioned. So I made the indexes on first name, then last name, and then date of birth. Okay. But now when I'm writing the query, I'm just writing where first name equals to maybe the Penelope again. Then we are skipping last name and then giving and DOB equals to maybe 1st June 1994. Okay. So in this case, we are skipping this last name part. So that is why B plus 3 indexing would not have worked in this case. Okay. And any condition is used after a range condition. So let's say in previously I said I could have used something like first name equals to Penelope and last name starts with A. Okay, I could have used that. B plus 3 indexing would have worked for that case. But in here, what I am doing is I am saying first name starts with P and last name equals to Garrett. In this case, B plus 3 indexing would not work. Okay. So this is all about indexing. You have already seen how indexing lets us query much faster and more efficiently by this cost effectiveness. Okay. So always try to use indexing where it is necessary, mostly on the columns on which we will mainly use in where statement. As you can see here, it is already written. Selecting what to index is probably the most challenging part to indexing your databases. But generally speaking, indexing works best on those columns that are subject of the where clauses in your commonly executed queries. So always use indexing only on the columns that you will use in the where statement. Creating unnecessary indexes can be a burden for SQL, and it will work like it will maybe slow down your query much more if there are some unneeded indexes in your system, in your databases. Okay, so guys, this is all for today. This is tip number 3, indexing. We will meet again where we will discuss the next tip, which will be tip number 4. Bye guys. We will meet again in the next video.